Okay, today we are going to continue chapter 4. We're looking at lesson 4, which is scientific notation. Now, this is something that you guys have probably seen before, maybe in your science class. I know you've looked at it a little bit. You probably haven't done it extensively, but you should have at least seen it once or twice before. Okay? So, the first thing we're going to do is we're going to take a number that's already in scientific notation, and we're going to express that number in standard form. Does anyone know what standard form would be referring to? Kind of, like it just basically would just be a regular number, okay? So scientific notation looks like this, 6.8 times 10 to the 5th power, okay? So in scientific notation, you represent a number using a decimal with only one value that's not 0 in front of your decimal, and then you always have a power of 10, so 10 to some exponent every single time when you're looking at standard form, okay? Now, if I want to change this into standard form, the only thing you have to do is move your decimal, okay? That's why I said we don't need a calculator today, because we're just going to be moving decimals back and forth, all right? Does anyone think they could figure out how many times I'm supposed to move the decimal, Kaylee? 5. How would you know that?
10 has 5 on it?
Yeah, because the exponent. So all you do is look at the exponent. So I'm going to rewrite 6.8 right here so I can move the decimal. Now, how would I know if I should move my decimal to the left or to the right? Anybody?
I guess.
Yeah?
It's negative. Like on the 5 where it's on the right side.
Well, who over here said if it's negative? Yeah, then if your exponent is negative or positive, that's going to tell you which one moves left, which one moves right, okay? Positive move right, negative you move left. Here's what I told my other classes. Think about a number line. If you want to go to 5, are you going to move 5 to the right or 5 to the left?
To the right.
5 to the right. If you want to go to -5, you'd move 5 to the left, okay? So all you have to do is take this decimal and move it 5 times to the right. So 1, 2, 3, 4, 5. What would I add in those blanks?
4 zeros.
4 zeros. Okay, so then I want you to rewrite the number so it looks nice and I can tell what it is. That's going to be 680,000. Now, here's another hint I always give, and you may want to write this down somewhere. Positive exponents will always give you big numbers. Is 680,000 a big number? Yes. So if positive exponents give you big numbers, negative exponents would give you what? Small numbers, okay? So let's look at an example of that. 3.25 times 10 to the -4. Okay?
Negative exponents give you little numbers?
Yeah, give me little numbers. So if my exponent's negative, would I move my decimal to the left or to the right?
Left.
I move it to the left. The exponent tells you how many times. So 1, 2, 3, 4, and I add in zeros, okay? Now, this is where my decimal ends, right? So before that, I should always put a 0, so I have 0 point, and then just write the number that you see. 0.000325. Is 0.000325 a really small number or big number? Small, right? Anytime you have a decimal with a lot of zeros that follow it, that's a really small number, okay? So again, negative exponents give small numbers, positive exponents give big numbers, okay? Somebody want to try the next one? 4 times 10 to the 2nd power. Dylan? Where is my decimal if I don't see it?
In front of the 4.
Behind the 4. It's always at the end if you don't see it, okay? How many times are you going to move that decimal? 2 to the right. Okay, what number would that give me, Dylan? 400. Okay, let's look at 1.3 times 10 to the -3rd. Somebody want to try this one? Again, all you're doing is moving a decimal. Reason, how many times am I going to move my decimal? 3 times to the left because it's negative. 1, 2, 3. Add in zeros in those blanks. What would you get as your final answer, Reason?
0.0003.
0.000?
0.003.
One, 3. Look at this number right here. Yeah. Okay. So be careful because you don't want to add in too many zeros, all right? Okay, how do we feel about that? Not bad? Okay, all right, let's do the opposite. Let's express a number in scientific notation. So these numbers will start out as just a regular number, so in standard form. And we're going to change them into scientific notation.
Drake Rainey, please come to the office. Drake Rainey, please come to the office.
Oh yeah, it's okay. All right, so on these, we have a regular number. We want to put the decimal back in. Now, where is the decimal if we don't see it?
At the end.
It's always at the end, okay? Now, does anyone know where I need to move the decimal to, Ryan?
Wouldn't you move it to the left because it made that a positive?
Yes, you do want to move it to the left, okay? So you want to move your decimal and you want it to stop when there's only one number that's not a zero in front of your decimal, okay? So where would that be?
4.
In front of the 4 or behind the 4?
Behind.
Behind the 4, okay? So I'm going to move it and I'm going to count. 1, 2, 3, 4, 5, 6, okay? So then I'm going to say 4. Do I need to put 4.0?
No.
No, right? If it was 4.1, yes, you would need to put it. But if it's 0.0, you don't really need to say that. It will always be times 10. Scientific notation is always written times 10. What exponent would I give it? 6, because I moved it 6 times. How do I know if it's positive 6 or negative 6?
Because it went to the right.
It went to the right, so it's positive.
Well, better than that, what was the hint I gave you about this type of a number?
Positive
Is it a big number or a little number?
Big number.
Big, yes. Big numbers give you positive exponents. Little numbers, because here's the reason I don't like to use left and right, because that depends on which form you're going to, okay? So just be careful on that. All right, let's look at 5,800. Okay, where's my decimal starting at right now, Ryan?
the at the end.
At the end, where do I want to move it to? Between what two numbers?
The 5 and no, the 8 and the 0.
You were right the first time.
Oh, 5 and 8.
5 and 8. Because if I move it right here, is there only one number that's not 0 in front of the decimal?
Yeah.
No.
No, there's two numbers right now. So I need to move it one more time because you can only have one number that is not 0 in front of your decimal, okay? So can you tell me what that would be? What would be my answer in scientific notation?
5.8. Did we do 2? Oh,
Yeah, you don't need the zeros anymore. So just 5.8
10.
times 10. How many times did we move that decimal?
3.
3. And it was a big number, so it would be positive 3. Okay? Okay, now let's look at this type. Again, I want to move my decimal to be to the right of the first number that's not a 0. So what would that be here? Between what two numbers?
7 and 2.
I want it to be between 7 and 2. So now I'm going to move it to the right. How many times?
2.
2 times. Okay. Can anybody tell me what would be my answer then in scientific notation, Vincent?
7.2 times 10 to the second power.
Negative.
Negative second power. Good. How do we know it's negative?
Because it's a small.
Really small numbers, right, produce negative exponents. Okay. Okay, somebody that hasn't gone yet want to try this one? Come on. YouTube already gone. Bella? Where do I want to move my decimal to? Okay, so how many times would I need to move it? 5. So what would be my final answer? How do you know it's negative 5? Small numbers, okay? Small numbers are going to give you that negative exponent, okay? All right, how do we feel about that?
Good.
Okay? Huh? What's up?
We don't have homework yet.
Almost. I got 2 more examples just on writing numbers least to greatest, okay? And we need to see it so we know, okay? All right, let's look at 2.4 times 10 to the second. 2.45 times 10 to the negative second, 2.45 times 10 to the positive second power, and 2.4 times 10 to the negative second. Okay, now, we're going to put these in order from least to greatest. Are they already all in the same form?
Yeah, they're on the same form.
Yeah, they're all in scientific notation, right? Do I need to move these into standard form?
Yeah. You should.
Do you have to?
No.
No, you don't have to, because you can compare exponents, and then if they have the same exponent, you can just compare the number, okay? So, which two numbers do we know would definitely have smaller numbers? The ones that have the negative exponent, okay? So then, all you have to do is look,
That one.
for the two that have negative exponents, which one has the smaller number? 2.45 or 2.4?
2.45. 2.4.
2.4 is smaller than 2.45, correct? So that goes first. So 2.4 times 10 to the negative second.
Skylar, Denny, please come to the office. Skylar, Denny, please come to the office.
Okay, and then we know 2.45 is the next one because it's the only other one that has a negative exponent, correct?
Correct.
Okay, then we look at the two that have an exponent of positive 2. If they have the same exponent, just look at the number in front. Which number is smaller?
2.4.
2.4, okay? And then 2.45 would be next. Easy enough, yes? Okay, you can write this down. Hey, write this next one down while I answer this. Hello. Can I call you back in like 5 seconds? Okay. Okay, so let's look at 9,562,301. 9.05 times 10 to the negative 6. 9.5 times 10 to the positive 6. And then 905,000. Now, notice on these we have two numbers in scientific notation, two numbers in standard form. So, shouldn't we change two of those to be in the same form?
Yeah.
Yes. You can choose either way. We're going to change them into scientific notation. So, who wants to tell me how to change this first number into scientific notation, Dylan?
Wait, like,
We just did this. All you have to do is move the what?
this.
Decimal, okay? Where do I need to move the decimal to?
What? Right. Left.
I need it to be between which two numbers, Dylan?
9.
The 9 and the 5. So 1, 2, 3, 4, 5, 6. So you could just say 9.56 would probably be enough. Times 10 to what power? How many times did we move it, Dylan? 6. Okay, can somebody else do the last one? Ryan?
It's at the end, and we move it to between 1 and 0.
Okay, I don't know why that keeps doing that. So 9.05 times 10 to what power? How many times did we move it?
5.
5. Okay, now on these problems, you guys, when I write them least to greatest, I will always put the original value. You need to write a new value so you can compare, but always write down your original. Okay, Reason, can you tell me which of those would be the smallest number? The one that has the negative exponent, good. Okay, so I'm going to start with 9.05 times 10 to the negative 6. Okay, the next smallest should also be easy to tell
9.05.
because it has what exponent?
5.
And the other two have an exponent of 6. So look at your exponents first, and that number was actually 905,000. Okay,
Oh, we have to write down numbers.
yes, always write the original. Okay, now, the last two numbers I'm comparing have the same exponent, so where do I look to see which one is smaller?
How many numbers are in there?
The number in front, right? Which number is smaller, 9.5 or 9.56?
9.5.
Just 9.5, okay? So we're going to say 9.5 times 10 to the 6th, and then our original number, 9,562,301. Okay, do we feel okay with that? Now, yeah. What if you had 4 different numbers that all had 4 different exponents? Would those be really easy to put in order?
No. Yes.
Yeah, they would, right? Because you just look at your exponents and put your exponents in order least to greatest. Are you with me on that, Kaylee? Does that make sense?
Yeah.
Okay, so it's okay for you to look at your exponents. If they have the same exponent, then compare just the number part. All you have to do is look at which number is bigger or smaller. Okay? We good? All right, here we go. We're going to do page 156.
Yeah, oh yeah.
A lot of instructions in that.
You should edit them.
Nah.
Can I get number 1 already?
That's what we're doing.
I did 332 too quick.